Factors affecting infiltration. Okay, infiltration, water soaking into the ground. Here's land A and land B. B is a steeper hill. The blue is me showing rain. Which will have more infiltration, water soaking into the ground? A or B? Think about it, get an answer. Think about it in your head. You thinking about it? I hope so. More infiltration will be A, okay? Because the water will run over it slower, more time to soak in. It takes a while to soak in. Here, when rain hits, it's going to really rush downhill, and water needs that time to soak in. So you have more runoff here, less infiltration. You have less runoff of rainfall and more infiltration. All right, cool. All right, please pause this, copy this now. Okay, slope of the land, steep slope, low rate of infiltration, gradual slope, more infiltration because the water will tend to sit there and not rush downhill. Soil saturation. If the soil is really dry, it can hold more infiltration. If the soil is pretty saturated, it's been raining for 3 days already, it can't hold a lot more. Water won't really go into the ground, it'll stay on the surface, flow downhill, be runoff. That's key. Pause this, copy it now. Okay, porosity. How does porosity of the ground affect infiltration? Well, if it's high porosity, it can hold a lot of water, you tend to have more infiltration, okay, because there's more empty space in the ground for that water to go. If the ground has high permeability, water goes through fast, it will have higher infiltration. You have low permeability, like really compacted clays, water will go in really much slower, less infiltration. It's reminding me, I was talking about it, I saw a video of it. They're making concrete that has high permeability and pavement for parking lots, so to create less flooding, so water will hit the pavement and go into the ground, thus creating more groundwater, creating less flooding. I just saw a video, they're actually using it now. There's a place in Albany where they actually paved the street with it. I gotta go there and do a video that I just reminded myself. And this is what the grass will look like. Vegetation. Pause it and copy this now, please. Okay, more vegetation creates more infiltration. And there's two main reasons. Most people think that the roots are like sucking up the water like a straw, like sucking it up. And it's not that, okay? It is, more vegetation has more infiltration. Roots help keep the soil loosely packed. So if you just dirt sitting there for 600 years, it'll get compacted over time by just gravity. But the roots help loosen the soil, so that makes more empty space in there for the water to go in. And the other key thing is vegetation slows the downhill flow of water. So as water flows downhill in this diagram here, it will flow really fast if it's just soil. Here, as the water goes down, all this grass and pretty awesomely drawn trees, as it goes down here, it'll really slow it down, all the stuff in the way, and give it more time for it to soak into the ground, infiltrate into the ground. Know that that's key. It's not about the straw idea and they're just sucking up the water. Plants do that, but at a much slower rate. Land use is the other thing. Humans' activities. Humans tend to really lower infiltration all the time because we either pack down soil, we cover it up, we build houses, buildings, roads. So most human activity will really reduce infiltration and create more runoff, leads to more flooding, less water getting into the ground. This is a problem in California during their droughts, where they want that water to go back into the ground to recharge the groundwater, but instead they have so many people there, so many roads and houses and buildings that the water runs off into the ocean, and they can't recapture that. So they actually build areas sometimes where water can collect to go into the ground, which is pretty cool.